2024, March 5th. Today's seminar is 510th, and the title is Satellite Mapping Reveals Extensive Industrial Activity at Sea. Is published by on Nature, and today's presenter is Jason Ho. Jason, the floor. Start your presentation, please. The floor is yours.
Okay, thank you. Today I would like to share this paper. The title is "Satellite Mapping Reveals Extensive Industry Activity at Sea," and it's published just a few months ago, and in Nature. On Nature. I'm Jason Hu from Indigo Waters, Taiwan. So let's start from the abstract. The world's population. Oh, sorry, I should interest in the team. This paper is mainly. The author is related to an NGO called Global Fish Watch, and. I can introduce this later. Sorry, I will introduce their website. Okay, so the world's population increasingly relies on oceans for food, energy production, and global trade. Yet human activities at sea are not well quantified. So we combine satellites, imageries, vessel GPS data, and deep learning models to map industrial vessel activity and ocean energy infrastructure across world's coastal waters from 2017 to 2021. We find that 72 to 76% of world's industry fishing vessels are not publicly tracked, with much of that fishing taking place around South Asia, Southeast Asia, and Africa. We also found that 21 to 30% of transport and energy vessel activity is missing from public tracking systems. Globally, fishing decreased by about 12% at onset of the COVID-19 pandemic in 2020 and has not recovered to pre-pandemic levels by 2021. By contrast, transport and energy vessel activity were relatively unaffected during the same period. Offshore wind is growing rapidly, with most wind turbines confined to small areas of the ocean, but surpassing the number of oil structures in 2021. Our map of ocean industrialization reveals a change in some of the most extensive and economically important human activity at sea. Okay, so I would like to share the Global Fishing Watch. They have a short video to introduce this project, this satellite mapping project. I think it's focusing on the result of this paper. So I think I can play this.
While the world increasingly turns to the ocean for food, trade, and energy production, the true scale of human activity at sea remains largely unknown. Mapping these activities can help us better understand the impacts of overfishing, environmental degradation, and greenhouse gas emissions. Supercomputers and AI can help. We drew on 2 million gigabytes of satellite imagery and machine learning to map out the world's last frontier, our global ocean. We found that about 3/4 of industrial fishing is dark to public monitoring systems, never being mapped to this extent before. In contrast, most non-fishing vessels, largely those dedicated to transport and energy, are broadcasting their location. but our satellite maps are revealing where there are still gaps in the public record. The satellite data also revealed the extent of offshore oil and wind development. We found that in the past few years, the number of offshore wind turbines recently surpassed the number of oil structures, with China's offshore wind farms showing the most explosive growth, a staggering 900% increase in turbines. We also tracked how activity is changing. Following the onset of the COVID-19 pandemic in 2020, fishing activity dropped by more than 10%, while energy and transport vessels were largely unaffected. Today, we see an ocean that is changing, and while fishing continues to be the most widespread activity across the seas, non-fishing activity, like shipping and offshore energy development, are growing more quickly, revealing an ocean where human use continues to increase and diversify. These detailed maps and monitoring can help us better manage this invaluable resource, providing information to highlight hotspots of unsustainable or illegal fishing, and provide information to inform sustainable development of the world ocean.
So, because it's a natural paper, so the structure is not like some other journals papers. So I will introduce this paper with my idea. So first, I will introduce how they create these maps. So they use satellite imageries, especially for this synthetic puncture radar. This is a satellite launched by European Unions, and it's called Sentinel-1. And this satellite has radars to detect the surface structure of the oceans, so they can detect any different some structure other than flat oceans, like ships, islands, wind turbine, oil platform. So this kind of thing, because radar can detect some hard substrate or hard stuff that can reflect the radio signals. So in these figures, in their extended data, figure 1, the colored area shows that they have the data from the satellites, try to identify all the vessels in the oceans. So you can see that most part of the open ocean, they don't have the image, because this satellite was designed to take photo of land, of people's or humans' activity on land. So they only, this is my guess, personal guess, I think the satellites only take photos or detect when it crosses the continental or lands, and it also took some photos, pictures along the coastline, but they don't have the image from in the far sea. But you can see they explain most human activity is very close to shore. They have other figures to prove that. So they say most of their study area already cover the EEZ of many important countries for fishery or some other ocean activities or industries. So the darker the color, it shows they have more overlap of the imageries from satellite. And on the right side, this figure shows the area or the size of the image they use every day. So this y-axis is area per day, square kilometer. So for me, I think this area is relatively small, because they only because this satellite will rolling average. I mean, it will cycle the Earth every 12 days. So it means every 12 days they can took photo on the same spot, but it won't. It will take photos on different areas, the interesting areas. So they collect. So they accumulate many images. So many images. I think it's maybe millions or thousands of images, and try to use these satellite image, the SAR images, to identify the ships and the vessels along the coastline in the EEZs. And then here you can see there's a drop here, because in this whole period they can get satellite image from two different satellites, the S1A and the S1B. But after this area, the S1B, I think, is retired. It's not start operating. So here in this period, they can only get image from one satellite. And because they use the AI to train the AI to identify the ships, so I think some people maybe know how the AI works. You have to teach them. You have to put a lot of effort to give the AI the materials to train them. So in this figure, they shows this satellite Sentinel-1's detection models is able to detect most industrial vessels. So this is in the x-axis is the length of the vessels. Like if it's a ship, so you can see this is a relatively small ship, and it's a very big ship. It's longer than 100 meters. It's a very big ship. And this is a fraction of detect. It means they provide them like exam to or test to the AI, and let them to try to find the vessels on the image, but they already have the correct answers by some experts. So so this figure is just like the result of a testing or a exam. So you can see if the vessel is too small, the detection rate is relatively small. So maybe if the ship is about 10 or 15 meters long, it's hard to detect by the SAR imaging. But if the vessel is big enough, the detection rates is very high. And another factor influence this detection rate is the vessel is isolated in that image, or there are many vessels in together come within 1 kilometer distance. So so this blue dot is some vessel will close to another vessel, so the detection rate will be lower. So maybe they will two vessels combined together, linked together, maybe they transport some goods. So the AI will think that is only one vessel, not two vessels, so something like that. But you can see the detection is better when the ship is big enough. Okay, then this figure on the extended data, that shows how they train the AI models. So I think they give the AI 3 different questions or missions. The first one is to try to find the ships. So they provide them 8,000 training data. They tell them in these 8,000 maybe pictures or vessels, they give them to teach them this is a vessel. And so the AI learned, and they give them a test, which is the whole out data here. They try to examine whether the AI can identify this 3,000 vessel or not. So that's why they can have this curve. They can have the detection rate. So the second mission for the AI is fission or non-fission vessels. So they teach the AI, this is like wind turbines, these are oil platform, it's not ship, not fishing vessel. This is, and maybe another type is fishing vessel. It's identified by human, by expert. And the last mission is the offshore infrastructures. And so they want to identify like wind turbine, oil platform, and others, maybe aquacultures or other human activity structures in the oceans. Oh, and another important thing to introduce to say is that they said the AI has some bias if the image is too close to shores, like the image too close to shore, there may be some waves, some small islands, and even some reflection from cars in the roads can be detected by the satellite or the AI. They will think it's ship because like some bigger cars, they can also have reflection because it's metals. So the AI will confuse, think a car drive across the shoreline is a ship. So they ignore or exclude some images in certain lengths along the coastline. I forgot the length. Maybe few meters along the coastline, they ignore the image that close. Okay, so I think I can show you the map on their website. Okay, it's well easier to let you understand. Oh, I forgot to introduce AIS. There's another important idea. Maybe you already know, it's AIS, the automatic identification systems. So it's equipment on a ship. So the IMO, the International Maritime Organization, I think it's asked all the ship larger than 300 tons. They have the responsibility to have this AIS. The original purpose is to avoid the two vessels collapse together, but it's a very good tools to track or to draw a map of the activity at sea. So it's based on some just like radio. The AIS will release radio signals, and that signal will tell the number of ships, the coordinate, the GPS coordinate, longitude, latitude of these ships. So other ships has a AIS receptors. They can calculate the speed of that ship, and some better AIS like computer can calculate if this ship will hit us or we can ignore that, or if it's very close, they will provide some like warning signal to the captains to avoid the collapse. So they have some basic information about AIS, but it's an important information that like this ground station and the satellites pick up this information, this radio signal, and making vessel trackable even more in remote area of ocean. So in this paper, they only use satellite data. I mean, some satellites can receive the AI signals released from ships, but it's very important to my personal understanding. Not every AIS can release stronger signal to reach the satellite. Some AIS is very weak, can only be detected in few like nautical miles, maybe I think larger than less than maybe 10 or 5 nautical miles. So some ships also have AIS but they can only receive by other boat, very close boats, or only can receive by the ground stations. Okay, I can introduce this later. So this is a map. I already give you the link of this map on the chat room of the webinar. So they have many layers we can use. Oh, here we are in Korea, in Japan. I think I didn't open any. Okay, the first is the AIS informations layers. So if we open these layers, and here we can choose the time, the year, the month, the day, even hours. So these are the information, the AIS information received by the satellite. So the color means every 500 kilometers, the density hours, I don't know. So if you zoom in, you can see the resolutions are getting higher and higher. So this area is highly, the highest possible of fishing effort. Oh, and you can pick up any spot, any square. They can provide you detailed information about the vessels. So let me show you.
Jason, I'm sorry disturbing you.
Yeah.
Jason, yeah. The hour means the hours per 120 square kilometer.
Yes,
on the left panel, the hour means stayed at sea, right? The vessel stays at sea.
Like,
so
yes,
they are fishing on the spot, right? My understanding is right? I'm asking you. I'm not sure.
I can check it later. Maybe they have explained this somewhere else. Yeah, but I think it's possible to show this kind of like a fishing effort, but because if the ships stay on the middle of the ocean, probably it's fishing vessel, probably they are fishing. So I just randomly pick up some square so we can see we have this TWM means our local fishing vessels, the vessel name, and some fishing vessel will provide detailed information like the type of the boat. So if we just point out some spot near China, so we can see that we have there are many Chinese trawlers and some other fishing vessels. So these are AIS informations. I mean, these are ships has these systems, but they have this very interesting. These are the vessels identified by satellite images. So the same I introduced in the paper, the SAR images. So you can see it's basically very similar. But these set of images, because they can only detect there's a ship or there's many ships, but they don't exactly name of that ship. So they can only suggest maybe these ships it will compare to the AIS information. Like in this area, like maybe this ship or this ship stay a longer time in this area. So probably these ships spend more time in this area. So let me just pick up. And it's very interesting. This data is not provided by marine traffic. I think it's so interesting. You can just track one vessels maybe in recent 2 or 3 years, where they go catch fish, where their fishing ground, and I don't know why maybe they their base is this fishing port, but one day they visit the south part of Taiwan. So this kind of details is very detailed, interesting. Okay, and they also have these line net detections, but it's relative lower vessels they have because they have used another satellite, the optical satellite, try to detect, because some fishing boat or some transport vessels, cargo ships will turn on the light so they can detect some light in the oceans, so they can draw another maps. So their goal is try to provide transparent information about the activity at sea. So if you have time, you can try to play with this map. We'll go to the slide. Okay. So they combine the AIS and the satellite AI image together, and they provide a, like in this figure, the figure 1, the title is about 75% of global industrial fishing and 25% of other vessel activity is not publicly tracked. So the means of public track is that the proportion of the vessel, like this, how can I say, maybe this, you can take a look of this Asia. They detect almost this number of vessels, but most of them are not was detected by the satellite, and only this blue portion of vessel is data is provided by the AIS, so that you can have this portion, and they call it proportion of not publicly tracked. But I think this idea of publicly tracked, it's not easy to understand, because some fishing vessel may have some fishing vessel in this part, they may have the AIS system just only because the satellite cannot receive that signal. So the local authority, maybe the country or harbor authority, can detect the signal. It's not globally publicly tracked. So I think it's slightly different about, I have the idea of this suggestion of this num. But you can see in Europe, the rate of public track is highest, and in this Asia or Indo-Pacific regions, the rate is low. Many activity is not tracked by the AIS data from satellite. And in the paper, they also provide more regional maps. In Norway, in Europe, and they have some like discussion or explain the map for the maps. Like these are the continental shelf, the age of the continental shelf. So probably there are more fish here. So it's more fishing activity at the fishing ground. And it's another map between Norway and UK. So you can see, because this Norwegian channels, so probably the fishing ground is belong to Norway. So there's more domestic fishing boat, and this Mediterranean area between Spain and Morocco. You can see the Spain ship mostly may have the AIS, but Morocco don't have. And it's Mediterranean, and this one is in it's in Yellow Sea. So you can see the area between China and North Korea, they have more ships, vessels is not publicly tracked, and also in Indian Oceans. And they have pick up some these figures. So I think also very interesting because it's a line of EEZ. So the EEZ also showed a very distinct like boundary of fishing activities. And in Thailand, I don't know why most of these vessels is not provide AIS signals. And in this figure 3, it shows the fishing activity with some human activity, the relationship with some human activity on land. So it shows the year and the density, the number of detected vessels in the oceans. So number of fishing vessels, you can see it has some patterns, and this pattern globally or outside of China. If we data from China, we can see that the pattern is strongly binding with Christmas and New Year vacations, the winter vacations. So every year of winter vacation, there will be lower fishery activities. And the pandemic also a very big impact because the vessels decreased about 14%. But inside of China's local domestic waters, it's another stories. So the one decline every year is related to the Chinese New Year, the Lunar New Year's. And another big decline, I think it's bigger and longer decline. It's related to the Chinese moratoriums. It means that the government will, at the beginning of every year, they will announce a period that no fishermen can go out for fishing in local waters. The year, the start and end virus different changes every year, but mostly it's begin on May, on June, and will end about around August. So every year, there will be a very obvious significant decline in this area, and also impacted by the pandemic. And this one is energy and transport ships, vessels. So you can see it's less impacted by the pandemic. And for inside China, the transport also influenced by these two important events, but it's less. But I don't know why the transport and energy were also influenced by the Chinese moratorium, because it's only related to fisheries. But why it's also influence energy and the transport? I don't know. Okay, and in this figure, it's not related to fish. It's related to other human activity, and they focusing the OEO infrastructure, which is the purple one. So you can see the here, the Mid-America and some Middle East and Africa has more OEO, offshore OEO platform, and the wind turbines. It's the hotspot. It's in Europe. I think it's between Norway and UK and Germany. And another bigger hotspot is in this area, and also in the shore of the lands and other structures. And I found the other human-made structure was include piers, power lines, aquaculture. So I think they have the ability to detect or to identify infrastructure of aquacultures, but they just didn't show on this map specifically. And in this figure, it's something about the industry, or like this oil vessel traffic, and the density of oil vessels and the wind vessels. So they compare the oil vessel and the oil infrastructure and the wind turbines. You can see this. The oil is not interested in numbers, but the wind turbines increase rapidly. But I think the comparison, because it's not compared to the energy, the amount of energy, just compare the number of infrastructures, because the wind turbines generate less energy compared to oil's platform. But it's also very interesting that maybe we don't know that it's so much or so increased so rapidly of the wind farms. And in this figure, this compare the different countries about the wind turbines. So most of countries are increasing, but China increased more rapidly in recent years for the wind turbine. And this figure shows the industry, I mean, transport and the energy related to the vessel. So you can see in Europe, the ships most of ships have AIS, and you can see the route is very clear. It's my personal guess. I think probably it's a different. Maybe the ship has also have the role of like keep right or keep left, something. So they have a very specific, very clear route shows on this map. And like in Malaysia, in the Indonesia, the Malacca Strait, so there are some also very clear route, but some locally route are not AIS or publicly tracked. And they call it a dark vessel or black vessel. I think it's very interesting because because the vessel also means blood vessels, and I think these are really blood vessel of humans, because we human, the economy or if many people's living is related to this, the transportation or fishing of these vessels of all humans, blood vessels. Okay, so I think most of them are very similar. In this area, this is the river mouth of Yangtze River, the largest river in China. And this is Shanghai, the biggest city. And this is a very important harbor, the Zhoushan business harbor areas. So most of them, these boats I think it's international cargo ships or other energy boats. Okay, do you have questions? Okay, let me keep going. This figure shows the fishing activity by EGs, and these are the number of ships. So we can see the biggest fishing activity countries: China, Indonesia, India, Vietnam, and the proportion of, you can see the proportion of publicly tracked and the not publicly tracked, and this is non-fishing activity. So Japan become the third. I think there are some common character of these countries. I think most of these they has a very long coastline, or they have many small islands. So it's very important to use the ocean as to transport energy or goods. And fishery also very interesting for this country with long coastline. Okay, here they show one specific findings in the EEZ of North Korea. So in this North Korea, Western North Korea EEZs, peak of fishing vessel activity coincident with Chinese moratorium on industrial fishing. So these are the number of vessels inside the North Korea EEZ, and it's very interesting that every year they will increase between the Chinese moratoriums. So probably it means that although the Chinese government don't allow the fishermen fishing locally, but fishermen can go to North Korea for fishing. But it's rapidly decreasing since the North Korea shut the borders, so there's no other country's ship can visit these areas. Okay, these are satellite imageries. Base detection allows monitoring at local scales. So you can see, like in Galapagos, because there are MPA, marine protected areas, so most of ships can only fishing outside, but you can see it here, probably a very important fishing grounds, because the fish don't know the border of protected area. So once they swim out, we're catch by those boats. But there's still some fishing vessels, probably illegal fishing vessels or IUU vessels inside the marine protected areas. And this also the Great Barrier Reefs areas in Southeast Australia, and these are the wind turbines in East China. And these are oil platform in a lake of some, I think it's middle or it's Venezuela of a lake.
Jason, I'm sorry,
yes,
but
yes.
Could you speed up, please? We have
Yes.
50 minutes and we'll have discussed time about 5 minutes.
Oh, okay. I think this, let me skip this. And this is related to the use of the oceans, because some fishing vessel will avoid the oil platform. So it's distant from the infrastructure like oil platform or wind turbines. But for the trawlers, they like to close to the wind turbines. But for the trawlers, they avoid the oil platform because maybe they will entangle or broken their nets. And okay, and this figure, this table, it shows the proportion. I think you already know from the maps the proportion of hours from AIS or hours from SAR. You can see a big difference because many of the vessels it's not shown by the AIS. Okay, maybe I could just pick up some important conclusions. So it reveals the real activity in the global oceans, and I think these are many countries that have reformed their fisheries now show actual decline in their fishing efforts. The decrease highlight in this study may reflect its longer trend, and we may already have seen the peak of fishing activity in the past decade. So probably the best time of fishing wild catch is already passed. Now maybe they were decreasing by the vessel or activities. And by contrast, transport and energy vessel traffic may continue to expand. In this scenario, change to marine ecosystem brought by infrastructure and vessel traffic may reveal fishing in the impact. I was very surprised by this conclusion. I never thought about this. If there is less fish, probably most ship in the ocean is related to energy or some other marine traffic. Okay, I have last two slides to provide some personal ideas, like the future application of this map, because on their website they provide API of their maps. So if we can find some IT people, maybe we can try to solve some issues, like maybe we can map in the sea-based marine debris, or identify the main source of sea-based shoreline debris. Like in these two figures, we have some remote beaches has this kind of debris compositions, but it's very difficult to tell the exactly source, because we can see ropes and these bottles probably from land, probably from ships, and styrofoam probably from aquacultures, some bumpers maybe from ships, and oil drums maybe it's for the engine of ships, and this buoy it's for aquaculture or is to aquaculture. So it's very difficult to tell who is the main source. So maybe this map can tell most informations, and we also I also think about maybe we can identify some specific fishery to try to calculate the areas, like this one. It's oyster farm near China, because the government already asked all the fishermen to use these alternative eco-friendly buoys, which is made by PET plastic, and so this is very colorful. We can see on the Google Maps. But this is in a house in Taiwan. The owner used these buoys, the marine, they collect in the coastline as marine debris to decorate their house. So although it's a better or alternative buoy, but also become marine debris, and it's our local oyster raft from the satellite images, and from the drones, it's so many raft, and each raft use many styrofoam buoys. So maybe we can combine this satellite technique to our studies project. Okay, this is my presentation. Thank you.
Thank you so much. And we'll have discussion and opinion times. If you have any questions, opinions, please feel free to tell us your opinion.
No. I was just wondering how they make the difference between the fishing boat and then other boats. Like, because I saw because they on their website I saw that they have a project of human trafficking. Not human trafficking. It's working force works, like the slavery, modern slavery happens on the fishing industry. So I don't know how they make the difference from the satellite. We consider that the length is the same and everything. So
I think they provide how to say, because they have AIS data. AIS data can provide more detailed information, like what is this ship is doing. Maybe it's fishing vessels or gillnet fishing vessels, some very detailed information. So they use this as a basic information and to combine with satellite image. So if the satellite in this specific time and date in specific area also find this boat, so they can tell the AI, oh, this is the fishing vessel, the type, the ship, the shape, the length, or the colors, I don't know, of this kind of ship are which fishing vessel. So the AI learns what is the fishing vessel, what is the oil platform. So
it's
this
pretty
kind
much
of thing.
The flight radar, yeah. Do you know the app Flight Radar, where we can trace?
I think it's not. The older tools they provide is on their website, I think. So if you check their website, they have many layers.
I'm on their website since you saw the website, and I was checking. Yeah, it's very interesting. Even though it's like the way you tracing, it's based on these graphic things, which is interesting. Thank you for the anyway. It's very interesting. I'm very into that, and because in Indonesia we are always talking about this Chinese and Taiwanese fishing boat that enter our zone, and then I saw your data and oh wow, Indonesia is on the number second. Now I can see the problem from different perspective, which is very interesting. Thank you so much.
Sure.
Thank you for the discussion. Jason, I have a question. Do they know about the nationality of the ships, vessels? With AIS data, they can track the countries of the vessel, right? And SAR data, they don't know about the originality of the vessel, right?
Origin.
The country ownership of the vessel.
Yes.
AIS data, they can track because
yes, because the AIS, I think you can only provide one country on the AIS signals, but I don't know it's a flag of convenience or just the real owner nationality of that ships. Most of those AIS data, I think they only have one country, like TWN or JPN.
They can also from I checked on their map. If you click it, it shows the flags also of the ship.
Oh,
so you know where they come from.
But the SIR data, they don't know the country of the vessel, right?
They can.
It's a satellite that they use, no? Like this, if you click here, one is Manchuri, is drifting long line from Ireland, things like that. It's very complete information on that.
Yeah, I think Chongshu is right. The satellite images can only tell there's a ship, and probably it's fishing vessel or it's cargo ship or other purpose, other type, but they cannot. They can only identify in this area what the proportion of AIS data, like maybe the Taiwan fishing vessel is more has higher activity in this area, but they cannot tell specific detection of from the satellite.
Thank you very much for the presentation. I just want to know, can anybody add some explanation about the difference between not publicly tracked and publicly tracked? I still don't understand well.
Oh, okay. The AIS will they have the antenna on the boat. Each boat they will keep release the name of the boat, the signal, radio signals about the location, the name of the boat. These signals, and some receptor. There are many receptor, like receptor from the ships and receptor from the land. Like this map show the. Okay, I have to read. Share the. Okay. Hello. Okay. So in this study, they use the satellites to collecting the information from the AIS. So if the satellite can receive the informations, they can put a dot on the map, says there's a ship on this spot in this day at this time. but many of smaller ships don't have AIS, or their AIS signal is relatively weak, can only receive from very local regions. So they will become the not publicly tracked vessels, because maybe it's big enough, longer enough to detect by the satellite, the SAR satellite, another type of satellite, the radar satellite. So, okay, so this one is our maritime and port bureaus. They have this map because they have some receivers on the coastlines. So this receiver will keep receiving signals from all the areas along the coastlines, so they can draw this map. But I believe if we compare this map to the global fishing watch net map, they were different because they can provide much more the information of smaller ships, but the local authority usually won't provide this information, open these informations. So maybe they can only show on this map, but they will not release the data because it's not open data for everyone to download or to link. So maybe, so yes, can you understand?
Jason?
Yes.
Mm-hmm. Then
Yes.
when I read this, have read this paper, I understood not publicly tracked vessel means if we have, let's think about this. If we have 100 vessels on the sea and AIS, it has AIS signal or not, and we have AIS signal 50 for 50 vessels, and we have SAR data. We combined both of data, then we found nothing
Some
with the
can
100,
match, some
just AIS data, 50 AIS vessel data, and combined AIS data and satellite data. We understand 100 vessel on the sea, then 50% tracked, 50% not tracked. I understood. That's right? I understand right or not? I'm not sure.
Yes, I
Just
think
basically, AIS,
Hmm.
according to the AIS data, we can compare with AIS plus satellite data. Then we can understand the discrepancy between them.
Yeah,
Then,
yes.
And Global Fishing Watch
Maybe
used AIS data plus SAR satellite data. So they
Yes.
tracked how much vessels are on the sea.
Yes, that's right, exactly. They want to show the real situation on the seas, because most of smaller ships or other vessels doesn't have AIS, or it's not public tracked, only nationally, domestically tracked, or very small scale tracked by their neighboring vessels to avoid hit-togethers, but it's not tracked by the globally tracked.
Oh, already it's over 11:30. Now it's 11:32. So if you have any questions, please send the email. Thank you for participating in the seminar, and thank you for your presentation for Jason.